Pelajar sendiri membuat aktiviti ringkas di mana mereka mencampurkan dua jenis garam yang terlarut tetapi akhirnya mendapat garam yang tidak terlarut. Semasa mereka menjalankan aktiviti tersebut, mereka sendiri dapat melihat bagaimana garam yang tidak terlarut itu diperolehi dan tidak sekadar mendengar apa yang saya beritahu ataupun melihat video yang saya paparkan. Contoh-contoh garam yang tidak terlarut juga banyak saya beri, di mana setiap kumpulan diberikan garam tidak terlarut yang berbeza. So dengan harapan pelajar memang akan ingat contoh-contoh nama garam yang tidak terlarut. Okay, now that you have identified the insoluble salts, okay, so we are now to prepare the insoluble salt. So if you can see on your table, okay, in the basin we have already prepared, okay, lab assistant has already prepared 2 solutions in a volumetric flask, okay, for you to carry out the experiments later. But before you can carry out the experiment, you need to know the method to carry out the experiment. Okay, what is the method? Precipitation. Precipitation. Okay, why is it precipitation? Because it's forming an insoluble salt. So a precipitate is formed in the beaker. Okay, then after that you got to filter, and once you filter, you will get the precipitate or insoluble salt in the filter paper. Okay, so now I'll show you a video of how to prepare the insoluble salt. So the salt that I've chosen here is lead 2 iodide. Okay, can you see the color of lead 2 iodide? Yes. Okay, what is the color? Yellow. Okay. Okay, if you can see, the materials needed here will be lead 2 nitrate solution, potassium iodide solution, okay, and then here we have filter funnel, filter paper, distilled water, okay, I'll explain later. We have beaker and measuring cylinder, but you do not have measuring cylinder in your list of apparatus, okay, because the chemicals have already been prepared for you, okay, and then you have how many beakers in your basin? 3, okay, 1 is for the formation of the insoluble salt, the other 2 you use for filtration. Okay, so here we have 2 reagent bottles. One is containing potassium iodide, the other one is containing lead 2 nitrate. Okay, so this is a very easy experiment. So you just need to pour. Okay, so yours you are getting it in a volumetric flask. So you just pour one salt solution into the beaker and then followed by the other salt solution. So it will be something like this. Okay, so the moment you have poured the second solution, you will get a precipitate. But the color of the precipitate depends on the cations. Okay, if the cations is from transition metal, then it will be colored. If it's not, then it's white. Okay, until here clear? Yes. Okay, all right. Maybe I get Kevin. What do you have to do?
Preparing insoluble salt.
Yes, prepare an insoluble salt. So what do you have to do actually to get the insoluble salt?
Pour 2 solutions in a beaker.
Pour the two solutions into a beaker. Okay, all right, and then you get your precipitate. Okay, after that, once you have gotten your precipitate, you prepare this setup of apparatus. So after this, I'm going to show you how to fold the filter paper. Yeah, so you place your filter funnel in 2 beakers and then fold 2 filter papers, place it inside the filter funnel. Okay, then use your glass rod. What is the function of the glass rod? Is it to stir? No, you stir before. Now you're using it to avoid spillage, okay, because we don't want the salt content or the salt solution here to spill out, okay, from the filter funnel. Okay, until here clear? Yes. Okay, good. Now we have to leave it, right, for gravity to do its purpose, yeah, or its job. Okay, so this is the next process. So this we will do in your next class. Okay, any questions so far? No. Okay, what about you, Hanif?
Teacher, is this a reversible process?
Okay, the process is non-reversible. This is a chemical reaction. Okay, if it's a physical reaction, for example, we have ice. Okay, ice. What is the formula of ice, Nicholas?
H2O.
H2O. Okay, sit down. Okay, Lai. What is the formula of water?
H2O.
H2O. Nishan, what is the formula of steam?
H2O.
H2O. Okay. Did the chemical formula change? No. No, because it is still the same substance, but it changes state from solid, liquid, gas. So that is called a physical reaction. But this is a chemical reaction. So you have two soluble salts, you add up together and you get one insoluble and one soluble. So the insoluble salt, if you add again with that particular soluble salt, it won't react anymore. Okay? So that is a chemical reaction. So now what you're going to do is, in your basin, you have two different solutions. Okay? Now, you just add the two solutions together in a beaker and then stir. How long do you stir? Yeah, until, no, not to say dissolve. It's an insoluble salt. It's not supposed to dissolve. It's supposed to mix well. Okay, so stir about 1 minute, alright? And then after that, you observe the color of the precipitate. So I'll just ask you at the end of the lesson. Okay, and then you prepare the apparatus setup for filtration and filter the salt solution. Okay, until here clear? Yes. Okay, you're going to start your experiment by folding the filter paper. So how do you fold this filter paper? Okay, first you fold it into half. Okay, and then fold into another half. And another half. And finally another half. So how many times do you have to fold? 4. Okay, 4 times. Okay, after that, you open back and you get, okay, some folded, how to say, like lines there. Okay, so you use this filter paper, the folded filter paper, try to fit in. So you use the folded lines, okay, to fit the filter paper into the filter funnel. But as you can see, the filter paper does not sit properly inside the filter funnel. So what I have to do is, I just have to sprinkle, okay, sprinkle some water, alright, like that. Okay, wet it. So use your fingers to wet it. And now it is sticking. Okay, clear? And then this you you place it in the beaker. And then you start to pour, right? When you pour your two solutions, and after that, you pour the solutions in this filter funnel and filter paper. And let gravity do its job. Okay, clear? Yes. Okay, you can start your experiment now. Okay, so now I trust that you have completed your experiment? Yes? Okay, so have you written down the chemical equation and ionic equation? Yes. Okay, so now group 1, please come forward and present. So he wrote PbNO3 bracket 2 plus 2Ki arrow PbI2 plus 2KNO3. Okay, and his ionic equation is Pb2 plus 2I minus arrow PbI2. So is that correct? Yes. Yes? Is that correct? Yes. Okay, but there's one slight mistake. The balancing is correct. Okay, the number of atoms is correct. Okay, but there's one slight mistake. Who can locate that? One slight mistake. It's at the first compound. Nothing to do with the balancing. Okay, since you cannot locate, look at the bracket. Okay, now this group uses a square bracket. It's supposed to be, it's just a, yes, okay, it's just the circular bracket. Alright, so please make correction after this, okay? So just rub off and then write a circular bracket. Is that clear? Okay, alright, you can sit down. Group 2, come. Come, Nicholas. Alright, so he placed it as Fe2SO4 bracket 3. Everyone here, yeah? Okay, plus 3Na2CO3, arrow Fe2CO3 bracket 3 plus 3Na2SO4. Okay, is that correct? Check the balancing, is that correct? Yes? Yes. Okay, so is that correct? Yes. Okay, because the balancing is correct. Okay, because here you have Fe2, here also you have Fe2. How many CO3? 3. So here? 3. Yes, also 3. Yeah, because the balancing is here. Okay, so his ionic equation is also correct. 2 Fe3 plus 3 CO3 2 minus arrow Fe2 CO3 bracket 3. Okay, thank you group 2. Okay, group 3, come. Final group. Come. Okay, he too has some corrections done, probably from the earlier discussion. Okay, so his chemical equation is PbNO3 bracket 2 plus 2 NaCl. So earlier you didn't balance, right? Okay, so PbCl2 plus 2 NaNO3. Okay, right, clear? Yeah, because you already make the correction. Okay, then okay, ionic equation. Not bad, huh? He has this flip system. Okay. Ionic equation Pb2 plus 2 Cl minus arrow PbCl2. Okay, so this is also correct. Okay, so thank you. Alright, we've come to the last part for today. Now, most of the salts that you studied, okay, we have soluble salts and insoluble salts. Soluble salts has plenty of uses, but the usage for insoluble salts are very limited. So, for example, okay, we have barium sulfate. Okay, did any group get barium sulfate just now? No, right? Okay, now barium sulfate is a white salt. Okay, it is used to actually help patients to help diagnose intestinal problems. Okay, intestinal, where's your intestine? Here, okay, somewhat down low. Okay, the barium sulfate will show up on the X-ray showing the shape of the intestine. Okay, so the doctors can then tell if there's any lumps or growth at the intestine. Why? Because when the barium sulfate is inside the intestine, it will show the projection of the image if there's lumps or growth. Okay, because like bones and what's the other material? Metal. Okay, bone, metal. That is why when you go to the airport, you want to pass through the metal detector. Okay, what will you ask to remove? Your shoes, your belt. Okay, all these can be detected. So same goes with barium sulfate. Now, some people might, or some of you might think, okay, if barium sulfate is insoluble, right, how can we ingest it? How can we eat it? We don't, alright? Why? Because it's actually toxic. But then, because it is insoluble, okay, it will not go to your system. So it will not go to the blood circulatory system. Okay, I think you studied, how to say, a bit in bio. The movement of substance across the plasma membrane, right? Okay, so this substance is insoluble, so it cannot pass through the plasma membrane, yeah, unlike other ions, because barium sulfate is already clumped as a solid. Okay, if it's just Ba2 plus and maybe NO3 minus, yes, it can enter, okay, through active transport, but not barium sulfate. So it's pretty safe to ingest it, and after that it will be, how to say, expelled from the body through defecation. Okay, so that's about it for today. Yeah, so I hope you are clear about the process of the production of insoluble salts. Okay, and then you know the usage of at least one insoluble salt. Generally, all of the insoluble salts are non-usable because they are all toxic. Okay, okay, clear about that? Okay, so any questions?
Teacher, I have a question. The chemical that my group made is really vibrant. Can it be used to make paint?
Okay, thank you, Hanif. I think I'm not going to answer that. Okay, maybe I get some expert from your part okay, from your side to answer Hanif's question. Okay, any volunteers? Thank you. Okay.
No, because the acid is made of sulfuric acid. You can use it to make paint, but not use directly as paint.
Okay, so you're telling me now that lead to iodide can be used to make paint, but not directly as paint. Yeah. So I cannot take lead to iodide and paint my wall, my house. Okay, alright. So, okay, Hanif? Okay, maybe we should check it out. Okay? So maybe when you go home, just check out, okay? Can lead to iodide be used as paint? Alright? Okay, so, and you can tell me the next class. Alright?